Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I dedicate to my lecturer, Encik Afian Akbar bin Musam, for this course, MTES3232, Curriculum Studies and Learning Theories in Primary School Mathematics, and to my fellow friends. My name is Nur Adlina binti Mohamad Nasir. I am from Mathematics 2 to PSMP. In this video presentation, I would like to present about applying learning theories in teaching and learning mathematics. Let me introduce you my content for this video presentation. First, introduction, and then key concept Piaget cognitive learning theory, application of Piaget cognitive learning theory in mathematics activities, implication of Piaget theory in teaching mathematics, implication of Piaget theory based on individual differences, key concept Brunel learning theory, application of Brunel learning theory in mathematics activities, implication of Brunel learning theory in teaching mathematics, implication of Brunel learning theory based on individual differences, conclusion, and last but not least, references. Let me start with my introduction. The teaching and learning of mathematics require the application of effective learning theories to enhance student understanding. This document explores how Piaget's cognitive learning theory and Brunel learning theory can be integrated into mathematics instruction. Special attention is given to addressing individual differences among primary students and applying constructivist approaches to facilitate learning. Additionally, the integration of this theory in classroom practice is discussed to ensure meaningful mathematical understanding and problem-solving skills. Key concept of Piaget cognitive learning theory. According to Piaget, schemas are fundamental building blocks of cognitive development. They are consistently being created, modified, and reorganized as we interact with the world. We adapt these schemas through process of simulation and accommodation as they encounter new experiences. This process is often described as discovery learning. Assimilation and accommodation require an active learner, not a passive one, because problem-solving skills cannot be taught. They must be discovered. Key points about Piaget theory. Schemas. Schemas are mental structures that represent concepts and experiences acting as building blocks of knowledge. Second, assimilation. Assimilation is integrating new information into existing schemas. Third, accommodation, modifying existing schemas to fit new information. Fourth, equilibration, the process of balancing assimilation and accommodation to achieve cognitive stability. Piaget identified four distinct stages of cognitive development. First, sensorimotor. Second, pre-operational. Third, concrete operational. And fourth, formal operational. Now, I would like to present to you my mathematics activities based on Piaget stages. First, sensorimotor stage for 0 to 2 years. Activity, the babies can explore shapes through touch, such as feeling different geometric solids. And the goal is developing an early sense of quantity and spatial awareness. Second, pre-operational stage for 2 to 7 years. Activity, the kids can using counting blocks or number cards to recognize the number. Goal, developing number sense and understanding one-to-one correspondence. Third, concrete operational stage for 7 to 11 years. Activity, solving addition and subtraction problem using manipulative like base 10 blocks. Goal, for they to understand conservation, reversibility, and logical reasoning in mathematics. Fourth, formal operational stage. Activity, solving algebraic equation using abstract symbols and real-world application. Goal, for they to develop abstract thinking and hypothetical reasoning. Next, we jump into application of learning theories and constructivism in mathematics activities based on Piaget cognitive learning theory. Main idea, children construct knowledge actively explanation, learning occurs through interaction with the environment. Students build understanding by manipulating objects and observing patterns. For example, a teacher introduced the concept of symmetry by providing students with the folded paper and asking them to cut along the symmetrical line to explore reflective symmetry. Encouraging active exploration enhances deeper understanding and engagement, making learning more meaningful. By incorporating hands-on activities, teachers align with Piaget constructivist approach, allowing students to develop spatial awareness in geometry through their own experiences. Moreover, cognitive development progresses in stages. Explanation: Piaget identified 4 stages of cognitive development, with the concrete operational stage for 7 to 11 years being most relevant for primary students. Example, to teach a fraction, a teacher provides cut-out circle representing pizzas and asks students to divide them into equal parts, reinforcing part-whole relationships. Ensuring that learning activities match students' developmental stages promote cognitive readiness and prevents frustration. The teaching sequence follows Piaget's stage theory by ensuring students first grasp concrete concepts first before moving to abstract mathematical reasoning. Apart from that, hands-on experiences are essential. Students in the concrete operational stage require physical objects to grasp abstract concepts. Using geoboards to explore geometric shapes allows students to physically manipulate and construct different polygons. Providing tangible learning material strengthens conceptual understanding and retention. Incorporating manipulative aligns with Piaget emphasis on sensory motor learning, helping students internalize geometrical properties more effectively. Furthermore, conceptual understanding precedes abstract reasoning. Before understanding mathematical symbols, students must develop conceptual knowledge through concrete examples. Introducing multiplication through repeated addition with counters before moving to numerical expression. This approach reduces reliance on memorization and fosters deeper mathematical comprehension. Let's move into application of Piaget theory in teaching mathematics. Main idea: teaching should align with students' cognitive stage. Mathematical tasks must be developmentally appropriate to meet students' ability. For example, introducing algebra too early without foundational arithmetic skills may confuse the students. Ensuring age-appropriate instructions foster confidence and academic success. Geometry lessons must align with student cognitive stage, such as using physical objects before introducing formal geometric proof. Main idea: active learning is crucial. Students learn best through engaging hands-on activities, allowing students to build 3D shapes with modeling clay instead of just drawing them. Enhance retention and deepens understanding by making learning tangible. Next, scaffolding and differentiation. This involves providing structured support when introducing new mathematical concepts. When teaching fraction, a teacher might first use visual aids, like fraction bars or bar charts, before gradually moving to abstract numerical representation. As students gain confidence, the support is reduced until they can solve fraction problems independently. Scaffolding helps students to build a strong foundation by progressing from concrete to abstract thinking. This ensures deeper comprehension, reducing misconception in mathematical concepts. Teachers can apply scaffolding by starting with hands-on activities such as using manipulative before introducing symbolic representation like equation. As we all know, all students have their own abilities differences. So, let me talk about implication of Piaget theory based on individual differences. Main idea: students develop at different cognitive paces. Some students progress faster in abstract thinking than others. Some students may struggle with fraction, while others excel in multiplication. Teachers must adapt instructions to accommodate varied learning speeds. Teachers must provide differentiated tasks based on individual cognitive readiness, ensuring all the students can engage with geometry meaningfully. Next, some learners need more concrete experiences. Abstract reasoning developed gradually, requiring ongoing hands-on engagement. Using fraction circle for an extended period before introducing symbolic fraction, ensuring struggling students receive the support needed before transitioning to higher order concept. Implication of Piaget theory based on individual differences. First, differentiated learning. Some students develop cognitive skills at different rates. Teachers should adapt tasks accordingly. For example, advanced students might explore algebra earlier, while students may need extended work with number patterns. Second, multiple representation for different learning styles. For visual learner, graph, diagram, and color-coded steps. For kinesthetic learners, they can use manipulative and hands-on problem solving. And for auditory learners, group discussion and verbal explanation. And the third one is student-centered learning. Instead of one-size-fits-all instruction, constructivism encourages personalized learning experience based on student prior knowledge and interests. Fourth, growth mindset and encouraging exploration allow students to make mistakes and learn through self-discovery, reinforcing that struggle is a part of learning process. Next, let me introduce to you three-concept Brunner theory of cognitive development. Emphasize tailoring instructions to students' developmental level and prior experiences. His goal was to create autonomous learners who had learned how to learn. Brunner hypothesized that the usual course of intellectual development moves through three stages. First, inactive. Second, iconic. And the third one is symbolic. Key points about Brunner theory. Cognitive constructivism is the idea that learning is an active process based on a person's background knowledge. Discovery learning is a teaching method that encourages students to construct new ideas through exploration. Scaffolding refers to the step taken to reduce the degrees of freedom in carrying out some tasks so that the child can concentrate on the difficult skills she is in the process of acquiring. Spiral curriculum is a teaching method that helps students transition between modes of representation. Concept formation is a teaching method that helps students categorize information. Culture is a set of value skills and ways of life that enhance a person's sense-making and communication. Application of learning theories and constructivism in mathematics based on Brunner learning theory. Inactive stage, hands-on learning for age 0 to 6 years. Learning through physical action and manipulation. For example, using base 10 blocks to teach addition and subtraction. Next, iconic stage. Visual representation for age 6 to 11 years old. Learning through image, diagram, and graph. For example, drawing fraction circles to compare different fractions. Next, symbolic stage, abstract thinking. Learning through symbols, formula, and equation. For example, converting real-life word problems into algebraic expression. Main idea. Learning occurs in three modes of representation. Brunner identified three stages. First, inactive. Second, iconic. And the third one is symbolic. For example, in teaching angles, students first use their arm to represent different angles, then observe angle diagrams, and finally use protractor for measurement. This step-by-step progression ensures students build a solid understanding before moving to abstract problem solving. This aligns with Brunner constructivist approach, where gradual exposure to different representation enables students to construct a deep understanding of geometric concepts. Main idea. The spiral curriculum reinforced learning. Brunner explained how this was possible through the concept of the spiral curriculum. This involved information being structured so that the complex ideas can be taught at a simplified level first, then revisit at more complex level later on. For example, students first explore perimeter by measuring classroom object, later calculating it for composite shapes, and eventually applying algebraic expressions. Revisiting concepts at progressively advanced level strengthens retention and prevents learning gaps. Using a spiral curriculum in teaching ensures that concepts such as measurement and area are reinforced over multiple grades, fostering long-term comprehension. The key principle for spiral curriculum is first, cyclical. Students return to the same topic several times. Second, increasing depth. Each time, the topic should be learned at a deeper level. Third, prior knowledge. Prior knowledge should be used when returning to a topic built from student foundation. Main idea: discovery learning fosters deeper comprehension. Students learn best when they explore mathematical principles through guided inquiry rather than direct instruction. For example, instead of telling the students the formula for the area of a triangle, teachers guide them to derive it by cutting rectangles into half. Encouraging discovery enhances problem-solving skills and critical thinking abilities. Discovery learning aligns with Brunner constructivist principle as students actively develop geometric reasoning through guided exploration. Main idea: multiple representation improve accessibility. Presenting concepts in different formats such as visual, physical, and symbolic helps accommodate diverse learning styles. Some students grasp fractions better through fraction bars, while others benefit from numerical notation and word problems. Catering to varied learning preferences ensure that all students can engage effectively with mathematical content. Next, implication of Brunner theory in teaching mathematics. Main idea: learning is a continuous process. Revisiting concepts at different levels allows students to refine their understanding. For example, geometry is first taught using simple shapes and later revisit with more complex spatial reasoning tasks. Prevents students from forgetting foundational knowledge and promotes lifelong learning. By structuring lessons progressively, teachers ensure that students build upon previous knowledge, a key element in Brunner theory. In addition, problem-solving skills should be encouraged. For Brunner, the purpose of education is not to impart knowledge, but instead to facilitate a child's thinking and problem-solving skills which can then be transferred to a range of situations. Specifically, education should also develop symbolic thinking in children. Brunner theory supports inquiry-based learning where students discover mathematical principles. Instead of giving the formula of area, students explore and derive it through guided activities. Develops independent learners who can apply mathematical reasoning in real-life situations. Next, implication of Brunner theory based on individual differences. Main idea: students learn differently. Some students rely on visual, others on physical interaction, and some on abstract reasoning. For example, providing digital simulation for visual learners and real-world tasks for kinesthetic learners. The impact: increases engagement and improve overall comprehension by catering to different learning styles. The variety of representation in Brunner theory support differentiation, allowing personalized learning experiences. Main idea: scaffolding enhance comprehension. Providing structured supports helps students progress through stages of representation. A teacher might first demonstrate solving an equation step by step before allowing independent practice to help the students to gain confidence and mastery over mathematical concepts. Implication of Brunner theory based on individual differences. For visual learners, use graphs, charts, and videos for explanation. For example, visualizing parabolas using digital graphing tools. And for abstract thinkers, challenge students with higher order problem solving. Example, exploring proof in geometry. Then, for hands-on learners, provide math manipulative. For example, using tangram to explore geometry. For slow learners, use a step-by-step approach before introducing symbols. Conclusion. The integration of Piaget and Brunner theories into geometry instruction perfectly embodies the core vision of the TBI, the big idea for MTES3232, content and pedagogy create effective minds. This approach harmonizes mathematical concepts such as geometry abstractions with constructivist pedagogy, including scaffolding and developmental pacing to foster deep and meaningful learning. By incorporating hands-on manipulative to support Piaget's concrete operational realness and employing Brunner's spiral approach to reinforce conceptual understanding, educators transform static content into dynamic, accessible knowledge. This synergy not only strengthens students' grasp of geometric principles but also cultivates critical thinking and problem-solving skills. Ultimately, it reinforces the TBI assertion that purposeful pedagogy unlocks the full potential of content, shaping adaptable and analytical thinkers for the future. Here is my references part. That is all from me. Thank you for spending your time and ears. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.